Today we are going to look at simple equations or one-step equations. We call them simple equations because there is only one movement that we have to make in order to keep our equation balanced. As we start our lesson today, I want you to think about the question on the screen. What does the equal sign mean? Many of you may think that the equal sign means the answer is. And when you're in elementary school, that's often true that is how we perceive it, because we have questions like 5 plus 6 equals, and we're asking you to find the answer. In reality, it means equivalent to. And that's what we have to start thinking of it as. We have to start thinking of it as that the two things that are on each side of the equal sign, whether they are two different expressions, two numbers, or an expression and a number, those things are equivalent or equal to each other. When we balance equations, equivalent to or equal to is how we need to think of this equal sign. By thinking this way, it will help keep our equations balanced or equivalent at all times. First, let's look at a model. If I were to ask you what you could tell me about these shapes, what would you say? Hopefully, you said something like 2 balls are equal to 1 cube, or 1 ball is equal to half a cube. Now, let's look at some numbers instead of shapes. If we have the quantity of 3 times 4 plus 2 on one side of our balance, and 2 times 7 on the other side, is our balance balanced? Because both sides are equal to 12, it is balanced, and we can say that the quantity of 3 times 4 plus 2 is equal to 2 times 7, or 12 is equal to 12. Now let's take a look at another set of expressions. Is this one balanced? After we do the math, we would find that it would tilt to the right because 32 is less than 48. So our expressions, quantity of 3 times 9 plus 5 is less than 6 times 8, or 32 is less than 48. Now let's look at our balance again. You've probably seen problems similar to this for years and have been required to fill in the box. Now we are going to replace the box with a variable. A variable is a letter that does one of two things. It represents an unknown value when we use an equal sign, or it represents quantities that vary when we work with inequalities, such as less than and greater than. We need to decide what the question is asking. This week, we are going to focus on the first use, representing an unknown value. Now, most of you are going to say this problem is pretty easy and you can do it in your head, but what happens if you don't automatically know what the number the variable represents is? We have to have a strategy to find out or solve for that variable, while still keeping our balance level. In this case, we're going to subtract 5 from both sides. So here you can see I've subtracted 5 on both sides of my balance. In a way, you can think of this as adding -5 to each side of the balance. I've also written it down below as the equation. The additive inverse says that by putting a positive and a negative 5 together, we will get 0. After I have removed the two 5s, the positive 5 and the negative 5, that x is all that's left. And so now I can see that x equals 7 minus 5, or x equals 2. Let's try another, this time with negative integers. When we look at negative integers in an equation, we must also take the negative sign into account. In this case, the negative is attached to the 6. We have to ask ourselves, what is the additive inverse of negative 6? It's positive 6 or plus 6. So I want to add 6 to each side to keep my balance. When I do this, I find that x equals negative 13 plus 6, or x equals negative 7. Notice how I am writing each of these directly below my first equation. I do this for two reasons. The first, to help me keep my equation balanced and easy to read. And second, to keep myself from accidentally saying that two numbers are equivalent when they are not. When we string a bunch of equal signs together in a horizontal line, we start saying things that we don't actually mean to say, because we're saying that certain numbers are equivalent to other numbers when really they're not. So we have to be really careful about that. I know some of you are thinking that this is so easy, why do I need to show all this work? I can do it in my head. By taking the time now to practice using small numbers, as you get to larger, more complex equations in later math, this year, for example, we'll be moving into two-step equations a little bit later. As you move into 8th grade, you will see variables on each side of the equal sign. And then as you move into high school math, it gets even more complex. This balancing act will become very vital for you to be able to solve those equations. It doesn't just apply to math, too. This also becomes important in chemistry when you're balancing chemical equations. You'll go through the same process of keeping the balance on each side of the equation, or each side of the chemical equation, to keep your chemicals equal. That's it for today on simple equations. I want you just to remember that that balancing act is very, very important. Although it may seem as if it's really easy now, once you reach those higher level equations, they do become a lot more difficult. So, if you have any questions, ask your teacher, and make sure that you are practicing balancing each side of your equation.